Hello class, today we're going to talk about section 6.3, which is elimination involving addition or subtraction. By the end of today's lesson, you will be able to solve system of equations using elimination. Last lesson we talked about substitution, which is one of the options to algebraically solve system of equations. Elimination is our next option. This is combining the two equations to get rid of one of the variables. Again, just like graphing, just like substitution, our solutions are ordered pairs because it is telling us where there's two lines intersecting. So, steps for this. First, you want to make sure that the equations are written so that the like terms lined up. X should be paired with X, Y with Y, and numbers with numbers. You are going to want to find which variable is the same, and you are going to decide if you need to add or subtract to get rid of it. Then you are going to solve for the remaining variable, and finally plug in that first answer to go back to get the second answer. So when we're looking at this, we've got 8b plus 3c is equal to 11, and 8b plus 7c is equal to 7. So the first thing we need to do is line them up. They're already lined up for us. So now we need to look to find the matching variables. So in this case, our matching variables are the b's. We've got 8b and 8b. Now we need to decide if we're going to add or subtract. If we added them, that's going to give us 16b. That does not make our b values go away, which is the goal of eliminating something, is to make it go away. So we don't want to add them up. Instead, we are going to subtract them. 8b minus 8b gives us 0b, which means that we no longer have that as part of our equation. Once I subtract the b's to get rid of that, then I'm going to have to subtract the remainder of the equation. So now I'm going to take 3c and subtract 7c, which is going to give me negative 4c. So because I subtracted the first two pieces, I'm subtracting the second two pieces. Then I've got 11 minus 7, giving me 4. So whatever you pick, adding or subtracting, you're going to do that with all three pieces in the equation. Now I've got negative 4c is equal to 4, So I'm going to divide both sides by negative 4 and get an answer of c is equal to negative 1. Then I'm going to go ahead and plug that answer back in. It doesn't really matter which equation you choose. I'm just going to choose the top one. So I've got 8b plus 3 times negative 1 is equal to 11. 8b plus negative 3, which just turns into subtracting 3, is equal to 11. Then I'm going to go ahead and add 3 to both sides, giving me 8b is equal to 14. And then I'm going to go ahead and divide by 8 on both sides and get an answer of b is equal to 1.75. And so my final solution here is 1.75, comma, negative 1. Something to note is that if they don't use x and y for variables like you would normally use on a coordinate plane, you want to list your answers in alphabetical order. So since b comes before c in the alphabet, your answer for b comes before c in your problem. Go ahead and try this one on your own, deciding adding or subtracting, and then proceeding from there. This one should be addition. In order to get rid of positive 6 and negative 6, you need to add those together. So we add it up and we get 7x is equal to 35, giving us x is equal to 5. Plugging that back in, we get y is equal to 2 for an answer of 5, 2. Next one. We want to make sure that our variables are lined up. So currently our y and our x are not above one another. So we're going to go ahead and switch this around. If I were you, I would always try and switch an equation that has positive variables so you don't have to worry about which sign goes with which set of terms. So I'm going to look at this top one, and I'm going to go ahead and switch that around. So the 3x plus 4y is equal to 22. So all I did was rearrange the order of the equation so that my terms lined up. Now, Since both of them match, I can pick addition or subtraction. Personally, I like to use addition when I can. So I've got 3x plus 3x, which gives me 6x. I've got negative 4 plus 4, which gives me no y's. And I've got 14 plus 22, giving me 36. I'm going to go ahead and finish solving for x, and I get an answer of x is equal to 6. When I plug that back in, again, it doesn't really matter which equation you plug it into. I always prefer to use positive equations. So I've got 4y plus 3 times 6 is equal to 22. Multiplying that out, I'm going to end up with 4y plus 18 is equal to 22. Subtracting 18 from both sides, I end up with 4y is equal to 4. And dividing both sides by 4, I end up with my final answer of y is equal to 1, giving me the final solution of 6, 1, writing it as an ordered pair. So there's that extra step to make sure that your variables are lined up. Go ahead and try this one on your own. Rearranging again using that top equation because both of them are positive. We get 14x is equal to 14, so x is equal to 1. Plugging that back into the first equation or the second one, either way, is going to give you y is equal to 4, giving you a final answer of 1, 4. If you have questions about lining up the variables, please let me know when you get to class. Last thing we have is word problems. So Taylor and Avery are throwing a birthday party for their friend. Taylor invited 5 fewer friends than Avery. Together, they invited 47 guests. How many guests did each girl invite to the party? So what we want to do here is declare one of them x and one of them y. I'm just going to put them in order. So we know together, or total, they invited 47 guests. So we have all together 47. Then it says Taylor invited 5 fewer friends than Avery. So we got her inviting 5 fewer than Avery. So if Avery did y, 5 fewer than that is going to be y minus 5, and that's going to be equal to Taylor. Our variables are not lined up right now, so we're going to want to go ahead and rearrange those. So I'm going to move the x over to this side, and I get y minus 5 minus x is equal to nothing. We don't want the 5 to be with our variables, so we're going to go ahead and add 5 to both sides. And that gives me y minus x is equal to 5. So now we're looking at this equation down here and this equation up at the top. So again, those aren't completely lined up yet, so I'm just going to flip-flop my x and y in the first equation. So y plus x now, and then we got y minus x is equal to 5. Again, I always prefer to add when I can, so I'm going to add these together because both of my variables match. 2y, the x's get eliminated, is equal to 52. Dividing both sides by 2, I get y is equal to 26. So that tells me that our y value is equal to 26. I'm going to go ahead and plug that back in. I'm going to plug that back into the second equation and go 26 minus 5 is equal to x. Solving 26 minus 5, I end up with an answer of 21 is equal to x. So what that is telling me now is that we want to look for the correct labeling here. So we've got Taylor, who is our x. Taylor invited 21 people. And we've got Avery inviting 26 people. Again, because it's a word problem, we don't need to write it as an ordered pair. Go ahead and try this one on your own. So we get -3 times x plus 5 times y is equal to -11. Then we look at our second part, and we get 3x plus 7y is equal to -1. Combining those through addition, we end up 12y is equal to -12. Solving, we get y is equal to -1. Plugging it back in, we get x is equal to -2. And I did write these as an ordered pair. If you just left it as y is equal to -1 and x is equal to 2, that is okay. If you pick different variables, that is also okay. If you have questions about this or anything else when you get to class, please let me know.